This is a 2018 question number 6, and this is your stat sensei, Mr. Spensey. So systolic blood pressure is the amount of pressure that blood pressure exerts on blood vessels while the heart is beating. The mean systolic blood pressure for people in the United States is reported to be 122. So on average, it's 122 with a standard deviation of 15. The wellness department of a large corporation is investigating whether the mean systolic blood pressure of its employees is greater than the reported national mean. A random sample of 100, and by the way, it's important they said greater. A random sample of 100 employees will be selected. The systolic blood pressure of each employee in the sample will be measured and the sample mean will be calculated. Let mu represent the mean systolic blood pressure of all employees of the corporation. Consider the following hypothesis. Describe a type 2 error in the context of this problem. So type 2 errors says that we are believing the alternative, but it's false. All right. A type 2 error occurs when we fail to reject a false null hypothesis. In this case, the wellness department would believe that the mean systolic blood pressure of its employees was no greater than the mean systolic blood pressure of the population, when in fact the employee's mean systolic pressure was greater than that of the US population. All right. So anyway, to get that, the description of a type 2 error, and we need to say, now I didn't address that it was the alternative was true. I said the null was false, and that will give me credit. Includes a description of a type 2 error and in context, which we did here. The next thing, so that takes care of the first part. So that is 2 components, 1 component and 2 component. Part B. The other part of the, and this is also the second part of getting the points. Assume that the standard deviation of the systolic blood pressure of all employees of the corporation is 15. So they're telling us, and they said assume, they're telling us that's the standard deviation of the population. The sampling distribution of X bar for samples of size 100 is approximately normal. So they told us that with a mean of 122 and a standard deviation of 1.5, what values of the sample mean of X bar would represent sufficient evidence to reject the null hypothesis? First off, let's talk about that 1.5. That 1.5 came from the standard deviation of X bar equaling the standard deviation divided by the square root of n, which is 15 divided by the square root of 100. So that's where that 1.5 came from. All right. So they're asking for a 95% confidence interval, which means our area and our tail is, are not, they want an alpha of 0.05. So this is our alpha equaling 0.05. So on our calculator, we're going to do a second vars inverse norm. Second vars inverse norm of 0.95, mean is 0, standard deviation of 1. And we end up getting a 1.645 for our z-score. All right. So X bar minus 122 divided by either 1.5 or 15 divided by the square root of 1 has to equal 1.645. When we solve that, we end up getting an X bar of 124.4675. You can solve it by algebra or you can solve it by inverse norm. But regardless, you have to have the z-score value. You have to show that the mean, and you also have to have the correct standard deviation, whether you put 1.5 there or 15 divided by the square root of 1, and then you have the correct response. So if I didn't do it by algebra, I did it by second vars inverse norm, I'd probably approach it this way. Second vars inverse norm, area is 0.95. Our mean was 122, and our standard deviation was 15 divided by the square root of 100, 124.467. Right, and you could have used the 1.5 for the standard deviation, and that would have worked as well. All right, so this would give you components that you have to have the context. You also have to explain what it is and reference the alternative. That'll give you the first two parts, and then parts 3 and 4 came down here. If you had all 4 parts, you get an E. Two or more of the 4 gets you a P. Moving on. The actual systolic blood pressure of all employees at the corporation is 125, not the hypothesized value of 122. All right, so this is the true value. We believed it was this, but the actual true value was 122. Use the actual mean of 125 and the results from part B. Well, what did we get in part B? We got a sample mean of 124.4675. Determine the probability the null hypothesis will be rejected. Well, what was our null? Our null was that the mean equals 122. All right, so the null was the mean equals 122, and the alternative was the mean was greater than 122. Turns out the population is 125. So if that's the case, what's the probability that we're going to get a z-score greater than 124? I mean, not a z-score, an x greater than 124. And really, I should say an x bar. Well, we know we're working with a normal. Our mean is 124. Our standard deviation is 15, and our sample size is 100. So I'm going to do a stats test z-test. Stats test z-test. My mean was 125. That's the true population. The standard deviation is 15. The x bar is the 124.4675. Our sample size, 124.4675. And our sample size was 100. We want to know the probability that it's greater than that. And when I do that, I end up getting a z-score of negative 3.355 and a p-value of 0.6387. All right, to receive credit, I had to show my mean of 125. I had to make sure that I included this value, and obviously I can place it here, but included that value, the correct standard deviation, the correct probability, and I had to indicate that it was normal. So either I told them it was normal or I drew a picture of the normal. All right. All 4 of those components get you an E. If you only have 2 of those, you get a P. All right. And actually that was included as part of 1. So really you really had to get 2 of the 3 instead of 2 of the 4. All right. What statistical term is used for the probability found in part C? Well, what we did was rejecting, and we're rejecting a false null. Well, power of the test, because the true population mean is 125, we should reject the null. The probability of correctly rejecting the null is power. So that's what we did. All right. Now they actually just took power of the test, but I feel like you should show some definition. All right. And the reason it was is 125. So we should reject and go from there. So, but they actually accepted power, but that was part of D&E. So suppose the size of the sample of employees to be selected is greater than 100. Would the probability of rejecting the null be greater? And increase the sample size would increase the power of the test. All right. That's a questionable response. I probably should have said it would increase the probability of rejecting. All right. Yes, power of the test is probability of correctly rejecting. So I'm sure they would have given me full credit, but they really wanted us to say, answer the question, which is specifically probability of rejecting. So make sure you answer the question. This is because the standard deviation of X bar, which is the following, will be decreased as N increases, right? So as N gets larger, the standard deviation of X bar gets bigger. In addition, this should be standard deviation of X bar. If the sample size were greater than 100, a smaller sample mean would be required to reject the null. They actually required that statement as well. I think that is ridiculous that they required it, but they did. Here's why they say that. We know it's z equals x bar minus mu over the standard deviation divided by square root of n. As this gets bigger, our power gets bigger, it's easier to reject. Well, if this got easier to reject, this value could be smaller and we still reject. So that's why they wanted us to say that. All right. Personally, I'd be really happy if you caught the fact that the variation decreased. At any rate, I hope this helped and look forward to seeing you on the next one. Thank you.